Okay, in section 3 we had talked about the factor theorem, and that this is when I take two polynomials which are expressions that have x's, x squareds, x cubes in them, and we test to see if they have factors. To have factors, they would need to get a remainder of 0. So we're going to illustrate that in this section, and we're going to illustrate that the factor theorem is telling me what the x-intercepts are. So a long illustration for that would be show that x minus 2 and x plus 3 are factors of f of x, which means 2x to the fourth, very long problem, all the way down to minus 18. Well, this is a long division problem. So we're going to take the lead term here, which is 2x to the fourth, and divide it by the lead term of the divisor, which is x. This will give us 2x to the third. And of course, that's going to go right over the 7x to the third. Now, a lot of books don't teach this, but you need to keep these columns straight. It'll help you to know when you're done with the problem. So next I multiply that through, just like in any long division problem. So I'm going to take the 2x cubed times x, and I get 2x to the fourth minus 4x to the third. And then, as in any good divide problem, I subtract. That means I change the signs. Now this first column is going to add to 0. It always will add to 0. You've got a big problem if it doesn't. The second column probably won't add to 0. It may. Then you bring down your next x squared column. Don't lose signs. Then you take the lead term of this next row, which is 11x cubed, and you divide it by the lead term of the divisor, which is x, and you get 11x squared. Well, that's going to go right above the 4x squared. So now I'm going to multiply that through. Let's get rid of some of this. I'm going to multiply that through, and I will get 11x cubed minus 22x squared. Subtracting, again, means this turns into a minus. The 22 turns into an add. This gives me 0. It always will. This will give me 18x squared. And I have to bring down my next weighting term, which is negative 27x. So I take the lead term, which is 18x squared, and I divide it by the lead term of the divisor, which is x, and I get 18x. And that goes above 27, x to the first power. And then I multiply that through, and I get 18x squared minus 36x, subtracting, meaning I change the signs, and I get 9x minus 18. So that 9x is divisible by x, the lead term here, divided by the lead term here, gives me 9. Hey, that finishes out my constant column. Let's see if I get a remainder of 0. Yeah, I get 9x minus 18, and if I subtract them, I get a remainder of 0. So that tells me something. That tells me that this x minus 2 up here is a factor. It tells me another thing. It tells me that x minus 2 is also going to tell me the x-intercept. X minus 2 equals 0, so x equals 2 will actually be an x-intercept. I'll show you that in a minute. Now there's a sign change there. Let's go on. Next thing I want to know is x plus 3. Is x plus 3 a factor? Well, to do that, I'm not going to go back to this original long problem. It's long, but I'm going to take this quotient here, which came out as a remainder of 0 again, and I'm going to use it. I'm not going to use this long polynomial. I'm going to use the reduced polynomial. And this is what it would look like, and let's put a division sign on that thing. And let's divide it. Lead term is 2x cubed from the dividend divided by the x of the divisor, and I get 2x squared, and guess where that goes? In the x squared column. Let's erase this. I need lots of space here. And so we're going to multiply that through, and I get 2x cubed plus 6x squared. And now I subtract, which gives me 5x squared. I bring down my next number, 18x. I take my lead term, 5x squared. I divide it by x of the divisor. I get 5x. I got a nice column waiting for that right above the 18. X to the first power. Multiply it through. I get 5x squared plus 15x. Now, good thing, I'm going to subtract here. And when I subtract, signs change. This first column gives me 0. Always will. Always will. Always will. And the second column will give me 3x. And then I bring down that little last 9 constant there. I ask myself, how many times does 3x, is it divisible by x of the divisor? And I get 3. Good news. I'm out of numbers. I'm out of columns. When I multiply it through, I get 3x plus 9. If I subtract it, I get a remainder. There it is, 0. What's that tell me? That tells me that x plus 3 is a factor. It also tells me that x plus 3 set equal to 0 will give me the x-intercept. Notice the sign change on this thing. Always get a sign change on that. So that is my x-intercept. So let's take that one step further. Did you know that this answer right here, 2x squared plus 5x plus 3, did you know that factors? It does. 2x squared plus 5x plus 3 factors into 2x plus 3 times x plus 1. Now that's kind of nice. I'm going to take each of those factors and set them equal to 0 and solve them. And when I do, I find that x equals negative 2/3 is an x-intercept. It's a 0. It's also called a root. Now those mean different things, but for now we're saying they're synonymous. On the second factor, I get x plus 1 equals 0, x equals negative 1, and I'm going to bring forward those two that I just did on the last 2 pages. X minus 3 equals 0, and oops, that's wrong. That should be x minus 2 equals 0, so this is 2. And then this one, x plus 3 equals 0, is x minus 3. So there are my zeros, x-intercepts, roots, different names for them, slightly different meanings. Let me illustrate that for you. I have off of the graphing calculator here this graph of the original polynomial, which had an x to the 4th beginning it. And I did it here, and you'll notice here the x-intercepts. That one's 2. Let's see if we can write on this. That one's 2. This one is negative 3. This one is negative 2/3. Or maybe it's that one. And this other one is negative 1. Let's go back and look at those. Negative 1, negative 2/3, positive 2, negative 3. They're all there. Now I've expanded those. If you want to see it a little better, it might come out a little clearer. Here it is again, 2, Here is negative 2/3. Here is negative 1. And here is negative 3. Notice they're all there. And you notice on the graphing calculator I've done a trace at the bottom. I'm emphasizing certain points here. Negative 1. Negative 1.5 here. And negative 3. Hey, bud.
What's up, dude?
Sorry, I got a math error here. I went back and looked at this, checked my work. Got a little math error right there. That should be negative 3/2, which is negative 1.5. And so we go back to our graphs, and we see that all that's true, negative 1.5, right?